In this video, I wanted to quickly explain how to use Linecalc in order to calculate the physical dimensions of a transmission line in order to realize a specific characteristic impedance. So to get started, let's open up a schematic from the ADS environment. For now, it doesn't matter what the name of the schematic is, so we'll just leave it as default. We're going to go to Tools, Linecalc, Start Linecalc. Now this is going to pull up a window that looks like so, and there are a lot of different types of transmission lines that we can use with Linecalc. So for instance, we have microstrip lines, which are labeled M lines. We have coplanar waveguides, which are labeled CPWG. We have strip lines, which are labeled S line, and so on and so forth. We're going to look at M lines today, or microstrip lines. Now here you can change the substrate. If we're going to use the default substrate, and we're going to define a relative permittivity. We're going to assume that we're using FR4, which has a relative permittivity of about 4.2. It can depend upon the material. We have a substrate height that is equal to about 19 mils. HU is the cover height. This assumes that there's some ground cover that's above the microstrip. In this case, they just set it to a very large number, meaning that the cover is very far away. T is the conductor thickness. For 1 ounce copper, this is about 1.4 mils. And we're assuming copper, which has a conductivity of about 5.4 times 10 to the 7th. Tan D is the loss tangent of the material. If we're assuming FR4, this is approximately 0.1 or 0.001. And then we don't need to worry about any of the other parameters for the time being. They're material specific parameters that you can change as you add more detail to the model. Now, we're assuming operation at about 850 megahertz. And we can go in one of two different ways. We can specify a desired characteristic impedance and a desired electrical length. So for instance, 50 ohms and 90 degrees. So this would be a quarter wave transmission line with 50 ohm characteristic impedance. And we could synthesize this line. By synthesizing it, it would tell us how wide we would need to make the line and how long we would need to make the line in order to have this characteristic impedance and this effective electrical length. The other alternative for us is that we could specify a width and a length, and we could analyze it, and it would tell us what the characteristic impedance is for that width and what the effective electric length is for that length of line. One thing to note that we might not have talked about is that a mil is kind of a weird unit that we don't always use, but a mil means 1/1000th of an inch. Okay, with that, I'm going to stop, and we will continue on next time looking at how to use a transmission line in an ADS simulation.